In this video, we'll discuss the Cartesian coordinate system. We can represent points in a plane, a two-dimensional space, by using the Cartesian coordinate system, named for René Descartes and sometimes called a rectangular coordinate system. Take two perpendicular lines, one horizontal and one vertical. They intersect at a point O, called the origin. The horizontal line is called the x-axis, and the vertical line is called the y-axis. Number scales are set up on each axis, with positive numbers lying to the right on the x-axis and above O on the y-axis, while negative numbers lie to the left on the x-axis and below on the y-axis. The number scales need not be the same on each axis, but the zeros of each number scale occur at the same point, the origin. Here is an example of a Cartesian coordinate system. Here is our center point O. Here is our x-axis, and here is our y-axis. And you'll note that in this particular example, we have the same scale. These squares, every step away from the origin is 5 units in any given direction. Any point on the plane can be represented by an ordered pair of numbers, p, x, y. The x-coordinate, or abscissa, is the first number in the pair, and the y-coordinate, or ordinate, is the second. The axes divide the xy plane into 4 quadrants, labeled 1, 2, 3, and 4, starting in the upper right quadrant and going counterclockwise around the plane. The distance d between 2 points, x1, y1, and x2, y2 in the plane, is given by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. To find the distance between -4, 3 and 2, 6, we say x1 equals -4, x2 equals 2, y1 equals 3, and y2 equals 6. So d equals the square root of 2 minus -4 squared plus 6 minus 3 squared, which is the square root of 6 squared plus 3 squared, which is the square root of 36 plus 9, which is the square root of 45, which is 3 times the square root of 5, or about 6.7. The order of points is arbitrary. It doesn't matter which point is designated x1, y1, and which is x2, y2. If we switch the order of the points in the last example, we have x1 equals 2, x2 equals -4, y1 equals 6, and y2 equals 3. So the distance is the square root of -4 minus 2 squared plus 3 minus 6 squared, which is the square root of -6 squared plus -3 squared, but -6 squared is the same as 6 squared, and -3 squared is the same as 3 squared. So we still get the square root of 36 plus 9, which is the square root of 45, which is 3 root 5, or this approximately 6.7. The equation of a circle is mathematically defined as the set of points that are a specific distance or radius from a given center point. So this is based on the distance formula. An equation of the circle with center C, HK, and radius R is given by x minus h squared plus y minus k squared equals r squared. So for example, find an equation of the circle with radius 2 and center -1, 3. The radius is given as r equals 2, and the center, CHK, equals -1, 3. So h equals -1 and k equals 3. Plugging this information into the equation for the circle, we get x plus 1 squared plus y minus 3 squared equals 4.